Imagine a world where cars don't just run on electricity, but on something you'd find in your cleaning cupboard, ammonia. That's what Toyota's thinking about.
Watanabe-san, as a chief engineer for Lexus Electrified, you know Akio's challenge to all of us.
Their big boss says this new engine might just be the end of electric cars as we know them. Sounds wild, right? Well, we've got 10 big reasons why they think so. Let's dive in and see what all the buzz is about with Toyota's game-changing idea.
レクサス乗ってるな、EV なんだということが
Number 1. Revolutionary introduction of Toyota's ammonia engine. In a bold move that could redefine the automotive landscape, Toyota has recently introduced a groundbreaking ammonia engine, signaling a potential paradigm shift away from the burgeoning electric vehicle (EV) market. This innovative technology arrives as a direct response to the increasing global momentum towards eliminating carbon emissions, particularly the impending bans on traditional combustion engines in numerous countries. Toyota's ammonia engine is not merely a technical novelty. It's a bold statement in the face of an industry rapidly pivoting towards all-electric futures. The significance of this development cannot be overstated. As countries worldwide commit to aggressive climate targets, the pressure on automakers to produce zero-emission vehicles intensifies. Electric vehicles, once seen as a niche market, are now perceived as the inevitable successor to the internal combustion engine. However, Toyota's ammonia engine challenges this narrative, suggesting an alternative path to a sustainable automotive future. Ammonia as a fuel offers compelling advantages. Primarily, it burns cleanly, releasing only nitrogen and water vapor, thus eliminating the carbon emissions that contribute to global warming. This characteristic alone positions ammonia engines as a potentially game-changing solution in the urgent quest to reduce greenhouse gases from transportation. Moreover, the introduction of this technology is particularly timely. As urban centers and entire countries announce plans to ban petrol and diesel cars in the coming decades, the automotive industry is at a crossroads. Toyota's Ammonia engine could offer a lifeline to the existing infrastructure and technology that support internal combustion engines, providing a more gradual transition path away from fossil fuels. Toyota's move is not just about sustaining its own business. It's about offering the world an alternative to the all-electric future. This isn't just another engine. It's a statement, a challenge to the status quo, and a glimpse into a diverse, more inclusive future of automotive propulsion. As such, Toyota's ammonia engine stands as a testament to innovation and a beacon for a potentially less disruptive, yet equally sustainable, automotive future. Number 2. Historical context and technological aspirations. The quest for an alternative fuel source has deep roots, with the aspiration for water-powered engines dating back over a century. Historically, the idea of harnessing water for automotive propulsion was a tantalizing one, promising an endless supply of clean, efficient energy. However, despite various inventors' efforts, technological and economic barriers have kept this dream just out of reach. The complexities of efficiently extracting and using hydrogen from water posed insurmountable challenges for early pioneers. These historical endeavors, though unsuccessful, laid the groundwork for modern innovations. Enter Toyota's latest venture, a revolutionary engine that rekindles the promise of water as a fuel source. Building upon the legacy of past attempts, Toyota is not just revisiting old technology, but revolutionizing it. Their new engine employs advanced methods of electrolysis to separate hydrogen from oxygen in water, then combusts the hydrogen in a way that's similar to natural gas. This process, while conceptually simple, represents a leap in efficiency and practicality. The implications of this technology are profound. If successful, Toyota's engine could drastically reduce the automotive industry's reliance on fossil fuels, curbing the harmful environmental effects of oil extraction and the mining of rare metals for electric vehicle batteries. This technology promises a nearly zero-emission future, where cars no longer contribute significantly to air pollution and climate change. The potential benefits extend beyond the environment, with the promise of reducing geopolitical tensions over oil and making energy more accessible and sustainable worldwide. Toyota's pursuit of this technology is a bold statement in a world teetering towards electric vehicles. While electric cars have been heralded as the future of transportation, they are not without their own environmental and ethical concerns. In this light, Toyota's innovation isn't just a technical advancement, it's a potential paradigm shift, offering a cleaner, more sustainable path forward. Number 3. The dark side of electric vehicles, EVs. In the midst of the electric vehicle, EV revolution, a less discussed narrative persists, the environmental and humanitarian concerns shadowing EV production. While EVs are celebrated for their zero emissions on the road, the process of creating them tells a different story, one that's crucial for consumers and policymakers to understand. At the heart of every EV is its battery, a complex assembly requiring minerals like lithium, cobalt, and nickel. The extraction of these materials raises significant environmental questions. Mining operations often lead to devastating land degradation, water pollution, and wildlife disruption. For instance, lithium mining in regions like South America has led to water shortages and chemical leaks, impacting local communities and ecosystems. But the concerns don't stop at environmental degradation. The human cost is equally alarming. In countries like the Democratic Republic of Congo, which produces more than half of the world's cobalt, reports of hazardous working conditions and child labor are rampant. Miners, including children, work in dangerous, unregulated environments for meager wages, exposing them to toxic chemicals without adequate protection. Moreover, the energy-intensive process of refining these minerals and manufacturing batteries contributes significantly to carbon emissions. If sourced from fossil fuel-dominated grids, the production phase can offset some benefits of the EV's emission-free operation. Understanding these hidden costs is crucial.
And we need the manufacturers to roll out new models.
It's not about dismissing the potential of EVs, but about pursuing a truly sustainable and ethical approach to our future transportation. As consumers, acknowledging these challenges helps advocate for responsible mining practices, better recycling technologies, and more comprehensive sustainability in the EV industry. It's a call to look beyond the surface and strive for solutions that are genuinely clean and just. Number 4. Toyota's multifaceted approach and diverse fuel strategies. Toyota, a name synonymous with innovation in the automotive industry, is not just pioneering. It's revolutionizing the future of transportation with its multifaceted approach to alternative fuels. This commitment to diversification is not a mere experiment, but a testament to Toyota's vision for a sustainable and varied future in automotive propulsion. The journey began with hybrid technology, a blend of gasoline and electric power, which Toyota mastered to deliver efficiency and reduced emissions. These hybrids were just the beginning. As the world leaned further into the green revolution, Toyota expanded its horizons to hydrogen fuel cells. These cells, representing a leap towards cleaner energy, use hydrogen to generate electricity, powering the vehicle with only water vapor as the byproduct. This technology isn't just a cleaner alternative, it's a bold statement in the quest for a zero-emissions future. But Toyota didn't stop there. The latest frontier in their quest is the ammonia engine. It's a concept that might seem out of a sci-fi novel, an engine powered by a substance commonly associated with cleaning products. Yet, the implications are far from fiction. Ammonia, when used as fuel, promises an engine that emits 90% less carbon dioxide than traditional petrol engines. Imagine a world where vehicles no longer contribute to the thick blanket of CO2 suffocating our planet. Toyota is not just imagining it, they're creating it. This diverse portfolio of alternative fuels isn't just about adhering to environmental standards. It's about leading the charge, challenging the status quo, and exploring uncharted territories. Toyota's commitment to these varied propulsion methods reflects a deeper philosophy. A sustainable future is not a one-size-fits-all solution. It's a mosaic of different technologies, each playing a part in the larger picture of a cleaner, greener planet. As we stand on the brink of potential automotive revolution, Toyota's pioneering spirit is indeed a beacon of innovation and sustainability. Number 5. Advancements in ammonia, engine technology and challenges. Advancements in ammonia engine technology mark a revolutionary leap forward, with Toyota and GAC at the forefront of this transformative journey. At the heart of this innovation lies the ammonia engine, a marvel that promises to redefine our approach to sustainable transportation. Unlike conventional engines, ammonia engines operate by either breaking down ammonia into hydrogen and nitrogen or blending it with other fuels to produce power. This groundbreaking method offers an astonishing prospect: vehicles powered without the carbon emissions that plague our atmosphere. However, the road to revolution is not without its hurdles. Developing a viable ammonia engine is a complex feat, challenging even for industry giants like Toyota and GAC. One of the most formidable obstacles they face is managing the increased combustion pressure inherent to ammonia fuel. This pressure, significantly higher than that in standard petrol engines, demands robust, innovative engine designs to ensure reliability and safety. Engineers are tasked with not just rethinking engine mechanics, but also reinventing them to accommodate this unique fuel source. Equally daunting is the issue of nitrogen emissions. While ammonia engines significantly reduce carbon emissions, they introduce the challenge of managing nitrogen, a byproduct of ammonia combustion. Excess nitrogen, if not properly handled, can lead to environmental concerns, such as contributing to smog and acid rain. Toyota and GAC are thus not just engineering engines. They're engineering a cleaner future, meticulously working to balance power with sustainability. These challenges are monumental, but the potential rewards, a world where vehicles no longer contribute to carbon pollution, are even greater, setting the stage for a truly astonishing leap forward in automotive technology. Number 6. Environmental benefits and manufacturing impact. At the heart of Toyota's revolutionary venture into ammonia engines lies the promise of significant environmental benefits. Central to this is the potential for drastically reduced CO2 emissions. Ammonia, a compound consisting of nitrogen and hydrogen, burns cleanly, emitting only nitrogen and water vapor when properly combusted. This starkly contrasts with traditional fossil fuels, which release a substantial amount of CO2, a key contributor to global warming. Consequently, adopting ammonia as a fuel could markedly diminish the automotive industry's carbon footprint, signaling a major leap forward in our quest for cleaner, more sustainable energy sources. However, the transition to ammonia-powered vehicles isn't without its environmental trade-offs. The current methods of ammonia production are energy-intensive, primarily relying on natural gas, which itself is a fossil fuel. This process, known as the Haber-Bosch method, also releases CO2, potentially undercutting the very benefits ammonia engines seek to provide. Moreover, the conversion of ammonia into a form usable by engines requires additional energy, further complicating its environmental impact. Acknowledging these complexities is crucial. While the potential reduction in CO2 emissions paints a hopeful picture of a cleaner future, it's imperative to consider the full life cycle and production chain of ammonia fuel. Only by addressing and optimizing these aspects can we fully realize the environmental benefits of ammonia engines and ensure a sustainable path forward. As Toyota continues to innovate, the industry watches closely, hopeful yet cautious about this potential turning point in automotive technology. Number 7. Global implications and industrial shifts. As we peer into the horizon of automotive innovation, Toyota's foray into ammonia engines isn't just a singular leap, but a potential seismic shift in global industry dynamics. The implications of this technology extend far beyond the garage and into the very fabric of consumer choice, industrial strategy, and governmental policy. In regions where the rumble of internal combustion engines might soon be silenced by law, ammonia offers a glimmer of hope. Countries across Europe and states like California are setting aggressive timelines to ban petrol and diesel vehicles, pushing the industry towards electric alternatives. However, the Toyota-GAC partnership's ammonia engine presents an intriguing third option, challenging the perceived inevitability of an all-electric future. This isn't merely about replacing one fuel with another. It's about reimagining the energy that powers our journeys. The adoption of ammonia as a viable fuel could significantly diversify consumer options. Drivers concerned about the range limitations and charging infrastructure of EVs might find solace in ammonia's promise. Moreover, the potential to retrofit existing vehicles with ammonia-based systems could make this transition more palatable and less wasteful, extending the life of millions of cars. Yet this isn't just about choice or convenience. The shift to ammonia has profound regulatory implications. Governments, having invested heavily in EV infrastructure and incentives, might find themselves at a crossroads. Supporting ammonia technology requires rethinking infrastructure, safety regulations, and environmental standards. The narrative of a zero-emission future remains intact, but the path to achieving it becomes more complex and varied. In this evolving landscape, Toyota's ammonia engine isn't just another option. It's a bold statement that the future of automotive technology might be more diverse and unexpected than we currently imagine. As industries and governments grapple with these changes, the world watches with bated breath, anticipating the next turn in this thrilling journey of innovation. Number 8. Safety concerns and practical challenges. As we delve into the innovative realm of Toyota's ammonia engines, it's crucial to address the safety concerns and practical challenges that accompany this groundbreaking technology. Ammonia, known for its high nitrogen content and potential as a zero-carbon fuel, also carries inherent risks due to its toxicity and combustibility, which raises significant safety issues. The toxicity of ammonia poses a substantial hazard. In its concentrated form, ammonia is corrosive and can cause severe burns upon contact with skin or eyes. Inhalation of ammonia gas can lead to respiratory distress or even fatal pulmonary edema. This presents a considerable risk in the event of a leak or accident, making the handling and storage of ammonia fuel a matter of serious concern. Safety protocols and emergency response plans must be meticulously developed and rigorously enforced to mitigate these risks. On the practical side, the combustion of ammonia presents its own set of challenges. Ammonia has a higher ignition temperature than conventional fuels, which means it requires more advanced ignition systems. Additionally, the combustion process needs to be carefully managed to prevent the formation of harmful byproducts, such as nitrous oxide, a potent greenhouse gas. Engineers are tasked with developing engines that can not only efficiently burn ammonia, but also do so in a manner that minimizes environmental and health risks. Despite these challenges, the pursuit of ammonia as a fuel is driven by its potential to revolutionize the automotive industry with a cleaner, more sustainable alternative to fossil fuels. As Toyota and other innovators forge ahead, they are not only navigating the technical complexities of making ammonia-powered engines a reality, but also the crucial safety and practical considerations that will determine their viability in our everyday lives. The journey is as daunting as it is thrilling, underscoring the delicate balance between innovation and responsibility in our quest for a sustainable future. Number 9. Public perception and policy implications. The advent of ammonia engines is not just a technological marvel, but a potential game changer in the global automotive market, particularly in major markets like China and California, where environmental regulations and consumer preferences are driving rapid changes in the industry. In China, the world's largest car market, there's a robust demand for traditional combustion engines. However, the country is also aggressively pushing for cleaner air and lower carbon emissions. This dual demand creates a unique niche for innovations like Toyota's Ammonia engine, which promises significant reductions in carbon emissions without completely abandoning the internal combustion framework. Meanwhile, in California, a leader in environmental regulation, strict emission standards and the move towards banning the sale of new gasoline vehicles by 2035 set a precedent for the rest of the United States and potentially other parts of the world. The introduction of ammonia engines aligns well with these goals, offering a bridge technology that can significantly lower emissions while the infrastructure and technology for fully electric vehicles continue to develop. As these engines begin to enter the market, they are likely to influence not just consumer choices, but also the future regulatory landscape. Policymakers might consider incentives for ammonia-powered vehicles or incorporate them into broader strategies for reducing transportation emissions. However, the success of these engines in influencing policy will depend heavily on their commercial viability, safety, and public acceptance. In this evolving landscape, ammonia engines stand out as a fascinating example of how innovative technology can potentially reshape market dynamics and drive policy changes, offering a cleaner, more sustainable future for the automotive industry. Their development and introduction are a testament to the ongoing search for solutions that balance environmental responsibility with practicality and consumer preference. Number 10. Looking forward. Industry reaction and future prospects. As Toyota unveils its revolutionary ammonia engine, the automotive industry stands at the brink of a seismic shift. This isn't just another alternative fuel proposal. It's a potential game changer that could redefine the future of transportation. Traditional automotive giants, who have long dominated the market with internal combustion engines, are now gazing into an uncertain future. Their well-established paths are being challenged not just by electric vehicles, EVs, but by innovative technologies like Toyota's ammonia engine. The ammonia engine comes with a promise: to significantly reduce carbon emissions without relying on the complex and sometimes ethically questionable supply chains associated with EV batteries. It's a bold move, especially as countries worldwide set ambitious goals to phase out fossil fuels. But with Toyota's ammonia engine, we might witness a transition to a more sustainable, eco-friendly automotive industry without the environmental and humanitarian concerns linked to EV battery production. However, this isn't a straightforward path. The introduction of ammonia as a fuel brings its own set of challenges and safety concerns, given its toxicity and the complexities involved in its combustion. Yet, Toyota's commitment to overcoming these hurdles demonstrates the industry's capacity for innovation and adaptation. As we look forward, the reaction from other industry players remains a critical point of interest. Will they view Toyota's move as a wake-up call and invest in their own alternative fuel research? Or will they double down on electric and hydrogen fuel cell technologies? The battle lines are not just drawn between traditional engines and EVs anymore. They now encompass a broader range of innovative solutions vying for dominance in a rapidly changing market. This is a pivotal moment for the automotive industry. Toyota's ammonia engine isn't just a new technology. It's a catalyst for change, sparking a revolution that could lead us into a new era of sustainable transportation. The industry's response will determine the path forward, marking an exciting, albeit uncertain future filled with innovation, competition, and the potential for a dramatically different automotive landscape. Thanks for watching another episode. While you are still here, make sure to click the video on your screen for more quality content.